We will proceed with our next speaker. Welcome everybody again. Welcome to our first parallel session. And we're going to have Andreas Schreiber from the German Aerospace Center, and he will talk about quantifying ourselves. We're very curious. Please go ahead. Yes, you may. Applause.
Okay, thanks. So this talk will not be too technical. It's about quantified self. Who of you have heard about quantified self, or is actually some kind of a self-tracker? Not too many people. That's good, because I'm going to explain what quantified self is. It's about yourself, myself. So that's the reason why I'm also talking a little bit about myself. You know, maybe more than speakers in other talks do. Yeah. And so I start with with an introduction of me. So my main job is I'm working as a scientist and head of department at the German Aerospace Center, or Deutsches Zentrum für Luft- und Raumfahrt. I'm leading the department for distributed systems, and we work on distributed systems naturally, high-performance computing and software engineering. We are located in Cologne, in Braunschweig, and in Berlin. Actually, we are just behind Kaufhof over there. There are our offices. Beside DLR, I co-founded the company Medando, where we are developing mobile health apps for Android, maybe. And I'm actually co-founded a Quantified Self meetup group. And I will talk about Quantified Self meetup groups a little bit later, especially the meetup group in Cologne, actually. And yeah, this is like a conference more or less about Python. And I'm a Python user since 1992, when I was at university. I found out actually that the most lines of code I write in Python is for Python versions 1.1, 1.2, 1.3. So after that, I was writing finite element codes and this stuff at that time. And nowadays I only write small chunks of code entering into IPython notebooks. That's more or less all. So. I'm involved in the Python community. I'm a member of the Python user group in Cologne, PyCologne. I was chair of the last PyCon Germany in Cologne, which DLR operates. And I'm chair of the PyHPC workshop. This is an annual workshop on Python for high-performance computing. The next edition will be in November 17th in New Orleans in the US. So related background regarding to this talk is there are two things, like the personal side and the professional side. The personal side, how I came to this stuff, quantified self, is I had a stroke 2009. It was an impressive incident in my life. I couldn't speak anymore at the time. I couldn't move my hand anymore. I had to learn all these things again, and I had to take care of my blood pressure and my health as a whole. So actually, this was very impressive, and I started then at that time thinking about health and tracking health parameters and thinking about training and therapy and all this stuff. So one of the outcomes was that I co-founded the company Medando, because I found out that a couple of apps that I would have loved to have for training and therapy wasn't available, like for speech therapy, mouse motoric training, and so on. So people at the rehab were kind of laughing at me when I was talking about apps for training this stuff. So I just developed an app for that. So the usual thing. So, and at DLR, the German Aerospace Center, we also deal with medicine, especially telemedicine a lot. This is mainly focused for space medicine, because you can imagine if you have people in space. So currently there's a colleague of us up there at the ISS, Alexander. He's there for 6 months, and there's no doctor around. So telemedicine And remote care is a very important topic in space and aerospace. So we deal with that since many, many years. And my department is like developing software and apps in this field, like for telemedicine and ambient assisted living. This is targeting on more elderly people, and especially also we are developing software for like space medicine. So this is the background. So I started with tracking my blood pressure and all this stuff, and then I found out that there's a, well, like a physiological context that is called quantified self. And quantified self is like, I mean, there are a couple of definitions. One is it's like self-knowledge through numbers. You are quantifying yourself, you're measuring things about yourself, and try to understand that, so that you can learn something about yourself. And sometimes with the goal to improve yourself, sometimes just to have like insights or so. You can like record daily activities like your fitness, sleep, your locations, very common stuff actually, and monitor and display this information from various devices. So I will come to examples later. There are other terms for that, like some people call it self-tracking or life hacking. Life hacking is especially if you are like try to change something in your life with certain activities, or life logging. This is especially where you are making like a whole picture of your life, what you're doing especially, and things like self-optimization, if you like to improve yourself. Self-optimization is very important for like people who are doing sports, professional sports persons and so on. A simple self-optimization example is like, if you have been here at the beginning of the week, is what was quite warm, so people were drinking about a lot of water, and there were a couple of cases of dehydration. So this would be a good case for like a self-experimentation. So how much water is enough to not collapse during the heat? You can like track your water, and I mean, if you're drinking one glass of water and then you collapse, that is obviously not enough. And you can go on and drink more and more water, and you find out what's the perfect amount for you. So there are, of course, apps for that. You don't have to like write it on paper or something like that. That's just a very simple example. The term quantified self itself is kind of a trend currently. It's in the news quite often, and also, at least in Germany and the US and maybe in the Netherlands, all the major newspapers had at least one article about it, or the TV stations are reporting about that, and so on. So this is a trend curve by Google Trends if you are entering quantified self. And there's also kind of the regional interest is very interesting. The most interest is in the Netherlands, United States, Germany, United Kingdom, not so much in other countries. And there are a lot of quantified self groups, meetups, where people are coming together and talking about their quantified self technology, what they are measuring, what are the outcomes, and so on. So actually, the Berlin meetups were 2 days ago, and the next meetup in Cologne is at September the 4th, actually. And currently, there are about 170 meetup groups in the world. The things that you can track is very diverse. You can, like, of course, track physical activities, insulin intake, location, blood sugar. You to-dos, like dimensions of your body. I mean, virtually anything. So the work that you are doing, the time schedule, almost anything. And the list of these words like grow every day. So the technologies for tracking all this stuff is also very, there are a lot of things. Most things are currently tracked with like mobile phones and apps. So the mobile phone is the most common quantified self tool today. A lot of people using web and desktop applications today. And more people are using special self-tracking hardware, quantified self gadgets or whatever, like wristbands and various dimensions. I here have it's a Nike Fuel Band. It tracks basically my activity. If I'm moving around, it calculates a value called Nike Fuel, which doesn't make much sense to me, so I use this only as a clock, but I have also like step counter. So many people are also using like self-made tools, especially Excel spreadsheets for that. And there are still a lot of people who are just using a pen and a paper for self-tracking. An important trend currently is that there are more and more wearable devices that you can buy. So, I mean, currently I don't know how many wristbands are available on the market. At least in Germany, you can buy more than 10 different wristbands from different vendors. You usually can track your activity and also like your pulse and maybe some other stuff. So, and I think we're converging more and more from like the human that we are now today to like humans like one of the Borg or something. Because the trend is now going from wearable devices that you attach from the outside of your body to implants that you, put into your body. So actually we at DLR are also working on that, putting input onto bones and measuring the elasticity of bones and this stuff. So my personal self-tracking is like I'm using sensors and smartphone apps. For example, the most important thing for me, the second most important thing for me is the step counter from the company Fitbit. This is a thing that I always hear on my trousers, a little thing. It's the most, this thing, especially from Fitbit, is the most precise thing. You can also use a wristband. This is not so precise, but it works too. Especially if you're comparing like relative results, the steps, if you're in steps, number of steps improving from one day to the other. Yeah. I use it every day. It's not like that I have to, but it's nice to know the number of my daily steps. I'm not saying that I'm addicted, but I'm feeling not really happy when I forgot this thing. So actually, this thing. Yeah, I'm actually measuring my weight with the technology today is like a digital weight scale which connects to Wi-Fi and then sends the data automatically to the cloud of the vendor of the weight scale and then to your smartphone app. And there are other wristbands, for example, this thing, WME, they promise that they can measure your stress level with your heart rate. Actually, I forgot it today, but I couldn't show it anywhere because measuring your stress level it takes 3 minutes. So you have to put your finger on this for 3 minutes and wait, and you don't allow to move for like a single millimeter to any direction. So then the measurement stops. 3 minutes today in our current daily life is a very long time, and so this is not very practical for daily use. Also, I use this only for like demonstration purposes sometimes or so. But I think this thing evolves and it will get better with the next releases. So I'm measuring my sleep. I'm doing that with my smartphone. It sleeps next to me. Yeah. One side of the bed is my wife, other side is my smartphone. That's the setup. You can see all my sleep patterns, for example, if I sleep well or not so well. This is also not very precise. If you go to like a sleeping specialist or a sleep laboratory and compares to their results, it's sometimes very different, but it's good enough to get you a hint about your quality of your sleep. Yeah, for me, actually, because my health is the most important value is my blood pressure. I'm measuring this with like regular blood pressure meters, as you can see in the picture. This is actually one of the apps that we were developing in our company, and I'm using and analyzing this data, how my blood pressure evolves over time, and also I'm using this to discuss my blood pressure with my doctor, and we we change the medication that I get based on the values. And actually, this app is like, it's not designed by software engineers, actually. So my doctor and other doctors have defined the analysis part of these apps. So that's the reason why it looks a bit different than other blood pressure apps. Yeah, and for location and also a little bit for my activity, I'm using another app called Moves. Moves is an app originally from Sweden, now acquired by Facebook a couple of months ago. This is quite nice. You can get a timeline of your day, the places where you've been at the day. For example, this was like if I was in a hotel and then went to a restaurant, and it says to me I was walking like 8 minutes, went 30 minutes by some kind of train, and then walked again 9 minutes, and then was at the restaurant for some time. And it also mapped this thing. So if you went going around, it maps all your ways. It's quite nice if you want to understand where you've been in the past. So I like this app. So since a couple of months, I'm also quantifying my car. So this you can attach to almost any car which was built after 1996. You can attach this little adapter, ODBD adapter. The port is somewhere below the steering wheel. It's a small Bluetooth adapter. It connects to smartphone apps which are in the app market. And they also track you where you are driving and your fuel consumption and a lot of other statistics. It is quite nice, especially for this app. I wasn't able to manage to export the data to analyze this, do correlations with my other data, but that's the plan. So actually, what I want to know here is, do I drive differently when my stress level is high, for example, or when I haven't slept enough or something like that? That's the kind of questions that I'm interested in. Yeah. So I'm also tracking my mobile phone usage, and my mood. This is the same combined app. It's from the University of Bonn in Germany, and it asks me like 2 times every day what is my current mood, and it can display this on a map, on location map, and so on. It's also quite nice. I like this app too, but currently I had a little bit of data loss for this app, so the first months of my data are lost, and the people from the university, I don't think they can get it back up, so I don't like so much anymore. Well, I'm tracking my weight with the app. That's not so important. And for Quantified Self, one thing is that you're tracking all the stuff, getting all the data. And side topic is like sharing the data. The thing is, what are you doing with the data? One thing that I'm doing is like I'm publishing some of my data to a certain Twitter account. Actually, I have like 2 Twitter accounts. One is like private and protected. The other one is more or less open. The use case is actually that it connects me and my values to my family. So actually my mother is reading the values via my Twitter account. And if my blood pressure is like a little bit high, then she immediately calls me and asks me what I'm doing, if I'm okay. So despite of the fact that I'm quite old now, so my mother is still treating me as a child, so, and she has no perfect vehicle to like control me. But I made it also the other way around. So I set up a Twitter account for my mother's blood pressure values and my mother's weight, and me and other family members can also control my mother. And I called you more than once. I called her more than once during the night when I figured out she was on the weight scale and weighted much more than the day before. So she get nice phone calls from me. So true, yes. Sorry. So the basic principle in Quantified Self is compared to traditional domains such as like telemedicine or so, it is completely human-centered. All the data belongs to the human, to yourself, to oneself. You can, like, as I said, measure a lot of things like productivity. You can take pictures, lab values, the posture, activity, and so on. The world around that is also important. Like if you want to have a complete picture and correlate your analyze your data relating to your surroundings, you can also consider your locations and the environmental data, weather, for example, weather, so your social interactions. So a couple of people I know are like tracking also personal relationships and the quality of their relationships and sex life and the stuff. You can also track your relationships and your interactions with your dog, and you can track your dog, you can track your car. You can also track, of course, and use the data from things in the Internet of Things, in terms of smart home. You can use urban data from smart cities and so on. And the other side, this is where the data is actually going. A lot of data is going to the smartphone, but actually many of these data chunks are going into the cloud, maybe into your own cloud or in cloud of different vendors of like quantified self hardware tools. And of course, especially if you are doing this stuff because of health reasons, then maybe the data is going to your doctor or the medical center or to your family or maybe to your health insurance. So that's the news trend that health insurance companies are interested in your health data. Actually, for a test, my health insurance is getting my step data, actually, currently. And other health insurance, at least in Germany, are working on these ideas. So a few words about the data. The data in the quantified self domain is very heterogeneous. We have data from the wearables and other devices. We have a lot of data from a huge variety of smartphone apps. We have also environmental data, social data, urban data, and so on. And the storage is also heterogeneous. We have local files and databases, and of course the cloud. One thing that you have, if you want to analyze it, you have to access the data. That's one kind of complexity. For many apps provide like export functions, and web services also provide export functions. You can get your data as CSV files or Excel files or JSON files. Some services and some, especially hardware tools, are providing APIs, especially if the data is stored somewhere in the cloud. Unfortunately, a lot of very good apps actually don't have any export functionality. So, I mean, with good apps, it's in the sense that entering data, tracking data is very convenient, very nice, and the possible outcome would be very interesting, but they have no API or export functionality. But from the community, there's a lot of pressure to these kind of apps to provide something like that. And another problem in this whole domain is that APIs of different vendors are very dissimilar. So there's no kind of standard or something like that. We also, like in the Quest community, trying to change that a bit. So an example for a web front end where you can export your data, this is from Withings, company which builds like digital weight scales and blood pressure meters and activity trackers and so on. So this is like my weight, and you have like a download button. You can either view your data on the web, or you can download and export your data via the web interface, for example. That's one thing. As I said, the APIs are very different. At the latest Quantified Self conference, we were starting about like getting an overview over the different APIs. They look. This is also from Withings. The API looks like that. I'm not going into the details. And for example, the API for another company like Fitbit looks a bit different, and APIs for other companies are looking very much very different, you know. And you have to deal with it. If you want to build your own quantified self tools or programs to analyze your data, you have to deal with very different APIs. And especially people who build like websites who wants to attach all kinds of sources, they have many problems with that. And especially some of these APIs of some vendors are not open. You have to apply to get access. For example, the Nike Fuel Band, I think there are only currently like 2 apps in the world who have access to it. So regular people like me and probably most of you are not going to get access to the APIs. That's a bad situation. To get access to get data from the API from Python is quite easy. I mean, for example, you can most APIs have authentication via OAuth, and you can like do REST calls, web service calls to it. And for the most common Quantified Self tools, there are special Python packages. For example, there's a Fitbit package for getting your steps data from Fitbit devices, or for Withings, the Withings package. It's all available on PyPy, and you can just install it on your local machine and import it. And you can get all the data. You can get your profile data on that with a simple call and get your steps data. This is from beginning of the year, I guess. There were days where I was working like 15,000 steps every day and so on. And of course, you can, like with usual tools, you can plot your data. And this is very easy, not very spectacular, you know. An important thing, of course, as in most application areas in data analytics today, is you have to homogenizing the data, because data formats are very different. So almost every app and every variable has its own format. There's no standardization currently. One problem is, or another drawback is that you sometimes only get already processed data. You're not getting the raw data of these devices. Usually they have accelerometers, and a lot of people would be interested in getting the raw accelerometer data and analyze it by themselves and applying different algorithms for it, for calculating the steps and so on. But most vendors doesn't allow you to get the raw data. So there's also a lot of pressure from the community that they open it, but it's not happening yet. And the best practice, what I'm mostly doing is like importing the data into pandas, data frames, and like some kind of working with it. It's quite obvious. Examples for this data as CSV export. This is from an app called Tablog. I'm using this app actually for tracking my coffee intake. Every time I'm drinking coffee, I push on a button, and then it records my coffee intake. The data format just for the coffee intake is quite complex. It also records the location where I am, like Bonner Straße in Cologne, in Köln, and Alexanderplatz in Berlin, and so on. It records the GPS coordinates. Especially one data set has like the 2 or 3 different timestamps. You know, we have a GPS time, there's a timestamp here. And yeah, they are storing the time again into separate fields, like here you have another timestamp and so on. Where is it here? Day of year, day of month, day of week, time of day, and so on. Very complex and very different to the data of other apps. For example, Fitbit, the activity tracker here. One thing, some people of you recognize that this is not English, so this is another thing. You cannot influence if it's English or German, actually, sometimes. If you're registered from Germany, you always get like German keywords and German tabular headers. And well, it looks different than the one before. And there's also the semantics of the word is not standardized. Yeah, even if you're comparing the data of different activity trackers, it's very different. And a very nice example, the Moves app is so. They can export very different formats: CSV, GeoJSON, RSS, GPX, ICAL, JSON, KML for Google Earth, and so on. And they're exporting like daily files, monthly, weekly, yearly files, all in one file. You get all the data, for example, if you're moving around here for BCC, my hotel back in, or my office here at Rosa-Luxemburg-Straße. It looks like that if you use the export of that. This is like one of the exports, just the places where I've been. You can also like export just the activities that you're doing. You can export some kind of a storyline. So just one single app can export very different file formats. One nice thing with this app, you can just import the icon into your like Outlook calendar and see all the things where you've been in the past week or in the past. So I have an Outlook calendar for like my last 1.5 years of my life. Every time I know exactly where I have been at that time. An example for very different file formats, especially the date formats. Like we have very different formats for dates, and very nice with technology that we're using with like pandas, is that it already handles a lot of these formats. Like parsing the standard strings is very easy, or if the dates are separated into different columns, you can just combine it during import, and so very convenient to use pandas for that actually. Coming to analyzing and visualizing the data is, this is really essential if you want to get insights. Yeah, what does the data mean? Does the data correlate to other data? What can I learn? Currently, there are a lot of websites arising in the market, like single-based ad app and so on, where you can import your data and they provide like single correlations and analysis functionalities. This is quite convenient for many people, but of course it's more fun to use like Python and IPython notebooks and pandas for that. I'm not using these websites anymore, but I'm using like just IPython for like simple visualizations. For example, this is like the distribution of my steps, like my daily steps. Most of the days I'm walking around a little bit more than 10,000 steps. There is like on the far left side you see a bar which is about between 1 and like 1,000 steps. That was a period in the last months. Actually, this is the data from the last 6 months. This was a period in the last months where I was in hospital and I was in bed all the time because I had some problems with my knee. So I can see this area in my life also in these charts. Other correlations are things like the sleep efficiency compared with the duration of my sleep. So I found out that for me, my sleep is not getting better if I'm sleeping longer. So it's better to sleep a few hours less, and then my sleep is a little better. Yeah. Sorry?
What is sleep efficiency?
Oh, that's some kind of that's a difficult question. This is some kind of a self-rating of your sleep that you're doing. This is a combination of self-rating of your sleep and the movements that you are doing during sleep. Yeah. Yeah, if you're sleeping very well, then you're moving much less, for example. And you can find answers, of course, like in typical big data applications where you even didn't know that there was a question, actually. It happens for me all the time. So when I was playing around with my coffee intake data, I wanted to like visualize completely different stuff, but then I found out this little nice bar chart. Actually on the x-axis, this is the hour of the day, like 10 means 10 a.m. and 20 means 8 p.m. and so on. That's the hour of the day. And so I just see that I'm drinking most of the coffee in the morning. I mean, some people know that, but I like it. I like it, and for me it's interesting to see actually on these charts that it's exactly true for me too. So I can now go on and like optimize that, for example, drinking not so much coffee late night or in the evening, or drinking more coffee late night or in the evening. That is the thing that I want to find out, because I'm now currently working on correlating coffee intake with my sleep sleep patterns and so on. Yeah, and a special topic which I'm dealing with is like visualization and data analytics on mobile devices, because many people use mobile devices for self-tracking. Some people are using only apps, they don't use any web interfaces and so on. And so I think, like, especially quantified self apps should have visualization and some kind of data analysis included. So, and I would love to do that with Python. So a requirement for that, this is not really fulfilled today, is that there should be good visualization components for mobile devices. I mean, the visualization components and visualization libraries for Android or iOS, you can do simple plots like that, but it's far behind the possibilities if you have like with matplotlib or with bokeh and all these new visualization libraries that are available for the web, actually. And that's a topic where we will spend a lot of time and effort in the future to improve the visualization components for mobile apps. And also we want to use tools like NumPy, pandas, scikit-learn also on mobile devices. So NumPy is no problem, it's already there. If you're installing frameworks like Python for Android and Kiwi, you can just use NumPy. But I don't think that pandas and scikit-learn have been ported to Android. At least I haven't heard of it. But this will be, we need it for applications. Currently we're using, we are doing prototyping, all this stuff, data analytics things with Python and IPython on the web or on the desktop. And then a colleague of me is porting this code to Java code for Android. That's the way how it comes currently into our apps, but we want to change it and use Python on the side. We also deal with machine learning. This is also a special topic of data analytics. For example, for typical use cases that we are dealing with is predicting behavior patterns. For example, medication non-adherence is an important topic, or for reminding people for measuring things such as blood pressure, or for advising people to get some sleep now, for example. Or other examples are we want to detect stress and depression. It's an ongoing research topic which is really important currently. We want to use it. We want to do it with heart rate variability, with wristbands and so on. And we want to detect depression based on the communication behavior on the smartphone. So if you are communicating less, that's an indicator for depression, actually. Yeah. And one example from the DLR that we are currently developing is we are measuring cognitive performance. For example, for pilots or for astronauts, we are currently developing a combination of hardware and software that they use during flights, where they doing a sleep tracking and they doing a psychomotor vigilance test. Basically, this is like a reaction time test. And the app, which is not completed yet, predicts their fitness level for duty. So if they are fit to fly or not, and they predict fatigue during flights. So they make a recommendation if the pilots should go to sleep for an hour or so on long-term flights currently. And if you want to try it, I have a prototype with me here. You can. This is our hardware prototype. It's just a little box that a colleague of me printed out in a 3D printer. It's not defined prototype, but the test is very simple. This is just a demo without the data analysis. You can start a test, then wait to the small lamp there. Now, no, it's not working. That's always why I hate online demos. So you can see reaction time 220 milliseconds. This is not very good. Good is below 200 milliseconds. Very good is about 150 milliseconds. Cheating is below 130 milliseconds. So the record, all-time record of our department is 137 milliseconds. That was from the developer of the app. So if you try it, it's with the cable. And that's the, yeah, should go to the microphone, right? It's with a cable. This is not very state-of-the-art today. All these quantified self gadgets today have like Bluetooth and this stuff, and you can see it's designed for the cockpit actually. So like companies like Lufthansa or Germanwings currently don't allow Bluetooth in the cockpit. Oops. So that's the reason why it has cable. Yeah, currently. So if you yeah, this is an ongoing project for Lufthansa. If you're going to fly with Lufthansa like in 2 years or with Germanwings in 2 years, please go then into the cockpit and ask for the final version of this thing. Say you have seen it at a conference at PyData in Berlin 2000 and what have we had, 14, and say greetings for me and say you want to try your PBT test again. And I think most Lufthansa pilots will let you do the tests then. Okay, current research, last slide. Current research for us is, currently we're working on like provenance of QoS data, like to get trust and traceability in the data, and to do privacy audits, standardizing APIs, and we're also working on code offloading to like offload heavy computations into the cloud. So this is important because these small devices don't have very much computing power, and if you're doing heavy computation on these slides, the memory consumption is very high. To prevent that, we want to like move computations into the cloud. Okay, thank you.
Yeah, first, thanks a lot, Andreas, and I think we have time for a quick question.
Thank you. You already alluded to the questions, what do you do with the data once you have it? And now I see two primary use cases, one being medicine and one more, let's say, lifestyle-oriented.
Yes.
With this self-optimization lifestyle-oriented, does it work? Because I'm just tracking the data, does it really help you? So if, for example, for your coffee example, do you really say, oh, I drank too much coffee there, I will change it? Or if, for example, if you wanted to advise somebody on weight loss, does it really influence behavior? Is it good to know, but what do I know? What's the next step?
Does it change behavior or not?
If you have the data available, that's the first step. But then you have to act on the data. And just having the data doesn't really help people who want maybe to change their behavior. So what are you doing there? Do your apps, for example, advise people? Do you provide...
Some apps, not only all apps, advise people. And many people are doing, or at least should do something of the self-tracking also for like medical reasons or at least health reasons. And doing this stuff with self-tracking and analyzing or seeing your data over time and especially comparing the data with other people's data, this helps for the motivation for doing measurements for a long time. And this was a problem for many domains in the recent years, that the motivation was very low for people for measuring themselves. But with all these new technologies, apps, data analysis tools, and so the motivation is very high for people.
Okay.
All right, then thank you again.